My name is John Sedgwick. The video I'm about to show you is of a final assembly of the individual custom-made parts of my recently finished miniature 32-inch carousel. The parts of which I designed or fabricated and or had made. First, I should explain that since the age of 12, my lifetime hobby has been woodworking, specifically marquetry, often referred to as wood inlay. Typically, as you can see, I choose projects that allow me to display my marquetry in furniture or other projects. After many years while demonstrating marquetry at wood shows in southern Ontario, Canada, usually with my miniature piano playing in the background, a 3-year project which I made and finished about 25 years ago, or teaching marquetry at woodworking tool stores, I would be asked, "What is your latest big project?" While I'm never short of other people's marquetry repair projects, in the summer of 2020, I began research on carousels. Now, yes, 23 years later, I began what would become an overarching project that would start and stop as I pondered solutions to previously unforeseen problems, while I waited for materials or other more pressing projects precedent. Most carousels, as you may have noticed, have a theme, typically just horses. However, many have horses, carts, buggies, and other items, while others have an assortment of zoo animals. After reviewing the many options, I chose the theme Roman times, which I reasoned it would give me more opportunity for graphic designs, which I use in the decorative part of the panels on the carousel. I think that I should cover how the internet has been valuable to me over the last 22 years, with the modifications and interpretations of graphics suitable for this project, as well as assets for such as gears, brass tubing, and the many other small hardware pieces used in the horse tack and the real hair for the tails. In my working life, which I'm obviously now retired, prior to retiring, engineering, design, and fabrication industrial production equipment was what I was doing. So I began with a familiar process for me, producing, designing, engineering drawings with AutoCAD, detailing the necessary individual parts. This 21-year project, which I completed in 21, has challenged me in these cases. First, making the base, which houses all of the electronic components and drive components. Second, all the actual design and the panels. All of these panels are specifically related to the Romans and the Roman legions and their Roman gods. All of this I gleaned, and pictures I gleaned from the internet, and used them as an interpretation for these panels. All of this is inlaid, none of this is paint. And obviously the horses, the chariots, and as you can see they go up and down. Now I'm about to show you all of this completely stripped down and built up from this point up. So without further ado, ladies and gentlemen, here we go. Okay, what you're looking at here is the end of my 20-year involvement in making an English merry-go-round. In further parts of this video, I'll explain the difference between a merry-go-round and a carousel, but for the moment, we're going to discuss this, why I'm doing this particular part. What you're looking at is the guts, or the mechanics, if you will, the electrics of what makes this particular unit work. What I have here is the base unit. What will happen here is that this part will lift off. There will be a lid go on top of this, never to be seen again. Then obviously this all comes back again, and when all this comes back again, you'll have the horses, you'll have the carousel, the merry-go-round, and all of the other components that go to make up this merry-go-round. Now, what I have here is hidden behind this door is a radio, an MP3 player, an SD card. All of this is now part of the mechanics. This is so that I can obviously look at and check any of the electrics that if there is a problem in this. I have two small fans which are used to cool the audio device. The reason for that is when the lid goes on this and covers it up, there is no real circulation in here, and I'm concerned that it will overheat. So I've mounted two fans, small fans in here. Now this latch is in place. Now we're going to come around here, and what you'll see is wonderful. I just dropped it. This is all remotely controlled. There are two parts of this, obviously the sound system and the drive system. The drive system is a small DC motor which has a ratio of approximately 400 to 1, and then that is in turn belt driven across, giving me a further 3 times the ratios, which is something in the region of about 1200 to 1. What I'm coming in with is 110 volt power. 110 volt power then is kicked down through a transformer. That transformer is bringing it down to 12 volts, so that everything in here is being run off the 12 volt, as is the radio, which is a typical car radio. I have 4 speakers, and as I said before, the control panel. Now the control panel is obviously operated by turning on the power. When the power goes on, what I'm doing is starting up the fans, powering the transformer, powering a series of control relays, and those relays, this will turn the radio on, putting power to the radio, and it signifies that. Now the power to the radio is on. It's not on, but there's power going to it. Okay? If I want the radio to come on, I will turn the radio on. The radio is now on. There is a Bluetooth, in this particular case, to my phone. Obviously I can play any kind of music through here. This is obviously your typical carousel music. Okay? I'm just going to put this on mute for a second. Now, the drive mechanism, it is controlled with a further remote. At the same time as I activated the remote, I also activated a speed control. The speed control is shown down here as a percentage of the overall fast dimension, so I can make it go faster or slower as a percentage. That's about it. Eventually all of this will obviously have all of the other components attached to it, but this will be hidden away. Okay, there you have it, folks. It's summertime now, and last time I was doing this, obviously I didn't need a hat for the sweatband, and it was winter time. Now we're in the summer, or it's early spring, put it that way, and very warm. Where I left off was we were doing the lower case and all the electronics that drive this. Subsequent to that, we're now into moving on to the next stage, which is mounting the base plate, which is this, okay? I put the lid on, obviously on top of the existing box so that it's now secure. This is the main capstan that's attached to the box. The drive assembly. I won't get into all of the intricacies of the drive assembly, except this is a DC motor. It's a 400:1 ratio in the gearbox, obviously mounted on the side of the main capstan. This capstan obviously never turns. This is the first of the main drive sprockets driving onto the main section of the merry-go-round. Again, I previously mentioned that I would tell you what the difference between a merry-go-round and a carousel is. A merry-go-round is the first original name for what is called in the rest of the world, but England, a carousel. There's a history behind it. I'm not going to bore you with the history of it. Suffice to say that the first merry-go-rounds were built in the UK, driven by steam. Subsequent to that, they all went to Europe and it got a new name. Anyhow, what I've done since the last video, obviously, is I've mounted this drive and mounted the base plate. The base plate will eventually have the horses and chariots on them. As I mentioned previously, the theme of this is Romans and Roman times. What I'm going to do now is start assembling this so you'll have a better idea. This is all hidden, as is typically a merry-go-round carousel in existing systems. Now, the first part of this assembly, which you saw before but you didn't see the base plate before, is the drive shaft. Or I should say, in this case, it's a capstan. Excuse me, Keith. The capstan is what is supporting the whole assembly. I'm having to position this. There we go. A carousel is supported on a main assembly, which you saw before, but before all you saw was this assembly sitting on the capstan. What happens now is what was hidden previously in the box below. This is what is going to hide all of this mechanism from sight. Now I've got to do it the other way around. I should have put this assembly on first. As you see, it's a very tight fit, and it's held in place with magnets. There we go, it's locked in now. Now I'll put the capstan in. an actual position that it has to go in. If it doesn't go in that position, it won't be at the right height, it won't be notched. There we go, I'm locked in now. That's going to be held in place and you're never going to see the workings of that anymore. This is the second part of what is hidden. That will be supported, but for the moment I'm going to put it down here. Now we put the merry-go-round wheel on. There's always a beginning and an end. And the beginning is the drive belts. I've got two in there only because I figure sooner or later one of them is going to go, and it's so much easier than having to take this whole thing apart next time around. So I've got two drive belts involved. Now to equate this so that you maybe understand it, if this was a car tire wheel, not the driven ones, but the ones that are physically driving the car, you can just spin it. I have an axle bearing here, an axle bearing at the bottom, and this will just spin freely, as you can see. However, we're going to be driving it. So now we've got to fit the bearing on. The drive belt on. Can you pause, Keith? Okay. And that's connected. Now you see the drive belt is connected. Now the way in which this now works have to mount the lower part of this drive on its main base. All of these things I've been working on, part of my problem of finishing this has mostly been all of the variables of dimensions that have to miss everything else. That one part, this is number 3, and this is number 3. Although things are of a similar dimension, this is not a Swiss watch. And as such, a 32nd of an inch this way or a 32nd of an inch another way, it doesn't meet. So all of these small different variations in dimensions make a major significant difference. So in making this and assembling this over the years, I've had to come up with a whole numbering system to know which part goes to where. Now, as we've already previously shown you, the drive mechanism below will drive this around. And the only way I can get it to go around against that is to support it So I'm just going to put 4 of these support rods in right now. And once I've got the 4th support rod in, obviously I can, in a later video, which we'll show later, I will be able to speed this up and not bore you to death with mounting. Overall, there are 16 of these individual supports, and 16 of them obviously is going to be like watching paint dry. So I'm not going to show you 16 of them. I'm just going to show you how I'm able to get these 2 sections together, and then we'll off camera I'll do the rest. There's a series of videos that will hopefully be all working together in all good time when my videographer, the intrepid Keith, okay, and next. Now, if you started baking a cake when I first started, hopefully you'll be finished baking the cake when I've got these 4 on. There is no quick way of doing this. I've chosen just to mount 4 of these, obviously, so that I don't bore you completely to tears. As you can see, I've got washers and special tubing, and all of these components I've found over the last 20 years and assembled to get to this point. Oh, those are not. I've lost a few of those in my time doing this. Of course, they always roll underneath the bench, never to be seen again, which is why I buy extras of almost everything. And of course they show themselves. Only one more. The boring part's almost over. Looks like a washer right there. So many washers and bits and now, as you see, this whole assembly now is supported by these outer rings, which in turn is running on this main post. Now, this, again by magnets, attaches. Now it's completely hidden from view. And around it goes. Now the next part of this video will be the mounting of this drive assembly, or this support assembly on top, which I'm going to show you now. Now originally I had plans for this. I drew them up. It took me about 6 months, and like all plans, and you've heard the expression, the best laid plans of mice and men. Well, that was the reality for what I was up to here. The best laid plans didn't quite happen the way I expected them to, and many things had to change as far as dimensions are concerned. One of them was this drive mechanism. I had originally made this drive mechanism in plastic. Not made it, but had it made with plastic gears. The problem with the plastic gears is they are injection molded, and as such are not that precise. So in a few moments I suddenly realized that this wasn't going to work. How these go together here, this is the main drives that come off, or the drives that come off of the center capstan. I have now adjustment to take it down. This in turn comes out across here. Horses are attached to this, and as that turns, where's my drive? When the key is locked in place, what will happen then is this will turn, and in turning, drive the sprocket up and down. It's not obviously lined up, and that's my problem right this minute. But what will happen, the next video you will see, is all of these mounted, 4 driven off of this, and as this is going to turn, you will see this drive the horses up and down. So as this goes around, that's how that part works. Now, one of the problems that this concept has is, how do you know that it's level? Well, I spent a lot of time trying to figure out how I was going to do that. And my eventual solution came from an old bicycle. Okay. I can tension these in the same way a bicycle is tensioned. There's little spoke tightening devices in there, and I can pull up and down to create the same way of a wheel is on a bicycle is true, by pulling and tightening, making sure that as this rotates, it rotates evenly all the way around. So that's where we are with this as of right now. As I said, the next video will have all of this hardware mounted for the actual drives. Well, hello again. Last time we were here, I was finally fitting these outside supports, which obviously now I've completed, as you can see. And you saw the open drive train in here, which has the belt on it that's driving off to the main perimeter of the carousel. Now, this is held together on there with magnets. Now, since I was here last time, obviously I've put in the main supports all the way around. Now this makes this whole assembly supported from the main capstan in the middle. Now, what is not turning is this center portion, which is the main capstan. On top of the capstan are this main bevel gear, which is fixed to that capstan and also not turning. However, on top of that then is an axle of the bicycle. That bicycle axle is now supported onto and there's a bearing on that, which rotates with the main structure of the carousel. This main structure, as it turns, operates these bevel gears, which are supported out from the side all the way out to the end. And obviously as this turns, the bevel gears turn. This is stationary, this is going to turn, and in turn that will drive this offset cam, and there's 4 of these offset cams, which in turn are going to cause the horses to go up and down. Okay, so the spokes from this bicycle are supporting the outside perimeter so that it doesn't sag. Now these are tight. I didn't tune them. Anyhow, they're nice and tight, so over time it won't sag. On top of the exterior, obviously, are these rafters. The rafters obviously are, I shouldn't say obviously, but physically, they're going to support these panels. These panels are sliding in here. All the way around. I'm going to leave one panel open. That one panel is plastic, so you can see what's going on. Damn flies. Okay? So you can see what's going on inside. But for the moment, we're going to leave that open. Put them all on in a minute. When those are on, this will rotate, which I'll start up in a second. What I have all around here are LED lights. These LED lights will flash on and off. Now I'm going to turn the carousel around about on. Reduce the speed a little. As you can see, the cams cause it to go up and down. Spur gear and the bevel gear in the center is stationary, but the bevel gears on the outside are turning with the lights going. And we'll be putting the panels on, and as I put the panels on, the panels are held in place by two items. One, there is a bolt on each of these sides, okay? And then this perimeter will go around. There's 8 of these. Get away. Each one of these panels will bolt onto the front all the way around with a clear panel on top. Now I'll put the panels on. Fortunately, they're sequenced. I'm going to stop it as I go. Number 7. As you can see, the perimeter freeze will then hold that all together, okay, as we go around. For the final, there will be a cap that holds all of those together and a small retaining ring on there that holds it down. Finally, what will happen is that all of the horses, chariots, will be mounted accordingly onto the shafts, and the horses will go up and down while the chariots. So that's the next step that we will be going to when you come back with the next session of this whole thing will be completed, hopefully. So that's where we're at this moment, getting very, very, very close to completion. There's a few other little gadgets that go on and little embellishments, but basically it's finished. The final video will show all of those little features, and my 21-year odyssey will be over. That's about it, folks. Well, here we are, finally, with the all of the pieces together that relates to the carousel. At the very beginning of this, I mentioned that there is something significantly different about a carousel and a merry-go-round. Both effectively are the same from the point of view of what they are. The significant difference is that an English merry-go-round or carousel goes clockwise, you'll notice. All other carousels everywhere in the world go counterclockwise. There is a reason for that, although it isn't initially apparent. If you remember getting on a carousel before, you would climb onto the carousel, and typically you would go to the other side of the horse to get on and go in a counterclockwise direction. If you next time you get on a carousel in North America and you go on the other side of the horse to get on, the reason being is you're getting on with your right foot and you're swinging your leg over. Now if you did that with a carousel going, or a horse for that matter, you'd be going in the wrong direction because the carousel in North America are going counterclockwise. The reason why carousels in England go this way, because they were the very first carousels to be built. And the horses were all pointing in that direction, and you would get on as you do normally with a horse. You get onto this side of the horse, you put your foot in the stirrup, and you swing your right leg over, in which case you are going in a clockwise direction. Also, when you get on a carousel in North America, and if you get onto the other side, you'll notice that the side facing outwards, which is referred to as the romance side, is highly decorated and painted. However, on the inside of the horse, although it's painted, it's not painted anywhere near to the same degree. So you have two sides of the horse. Although it's carved the same way, although the carving is not quite as detailed, okay? That was done in order to reproduce the horses in a much more industrial way, to make lots of horses quickly. However, all of the sides of a carousel in the UK, they're both carved evenly, they're both painted evenly. Anyhow, so much for the history of carousels and direction. Finally, as we've also previously gone over, this is now currently being driven by a variable speed DC motor, and that motor obviously is driving these poles, horse poles, up and down, attached to the chariots. The horses were carved. All of the tack was cut from sheets of leather. All of the strings, all of the buckles, all miniature. Amazing these days, you can buy almost anything on the internet, which I must manage to find. All over the world they come from all these small individual parts. Now the chariots themselves, obviously I purchased the wheels. The individual carvings I made representing lions and the eagle, these were all representative of various legions and the insignia of those legions. All around on the inside, In the lower portion are the legion names in, I would assume it's Latin, okay, or Roman. Above the Romans name are all of various Roman images. All of these I gleaned off of the internet. Around the perimeter you have Roman gods and goddesses, charioteers, various coats of arms which related to also the Roman legions, gods or goddesses. This is all attached to the perimeter which you saw in bare form. Now obviously I've put on the roof, which previously you saw open, has now been panelled. In order to show you what's going on inside, I left one panel open with a clear panel on it, with all the fairy lights inside. Of course, don't see the fairy lights light up as well until such times as it's nighttime, then you can really see them light up. And finally capped off, this is not metal, it's wood, and the little O-ring holds it in place, keeps all of these tied down. And there it is, there's the entire carousel completed. As you heard in the background, music is playing. That music is hidden behind here. It's all being played right now off of this SD card. It will also play Bluetooth or whatsoever. I've got many songs or tunes on here, if you will, including conventional carousel music, which I'll however, somehow chariots and charioteers, which is the whole theme of the Roman times, doesn't seem to fit with this kind of theme, but nonetheless that's the traditional carousel merry-go-round music. So we go back to what I was playing before, which is more, let's say, theme appropriate music. Okay, theme appropriate music we're discussing here is the more dramatic kind of music that you would expect. Okay? We're pretty well done. It's all inlaid, it's all been French polished. This is one complete unit. I can obviously take it apart because I put it together, but nonetheless it has to be transported as one piece. And ladies and gentlemen, that's all she wrote. After 21 years, that's it.